Let's see how to estimate and forecast using seasonalities. Here we have gasoline sales from 1980 to 2001, April, it's monthly data. Let's look at a graphical representation of the data. You can see that it has been going up over time, so there is some trend there, but there is a very strong seasonality. So the series is from 1980 January to 2001 April. We're splitting it into in sample and out sample, out of sample, and then 3 years worth of data for forecasting. Let's evaluate 3 models, one with just seasonality, one with linear trend and seasonality, and one with quadratic trend and seasonality. So let's go back to EViews. We will create some dummy variables, one for each month. Before that, let's set the range to include the forecasting forecast horizon. So that's still 2004 April. Yes, I want to resize. Okay, so just to be sure, the forecast horizon is up to 2004 April. Perfect. So now let's generate series. So you want to create 12 different dummy variables, one for each month. So let's say D1 is for January. I think I was in the right place, but never mind. So D1 equal to at SEAS, season, parentheses 1. This will create a dummy variable for January, so 1 for month for January, and then 0 for other months. So you can see every January the D1 takes a value of 1, other months it's 0. All right, I copy pasted the equation for E, so now I'm just pasting it and replacing this with 2. Okay, and season 2, SEAS 2. All right, so you keep doing that for all the 12. Okay, 3. I'll pause here, and then it's the same thing. I keep on repeating to create 12 of these series. As you can see, I've already created 11 of the dummy variables. I'm now working on the last one. So this will be for December. D12 is equal to @sys 12. All right, so 12 dummy variables, one for each month. Now we can go ahead and estimate the model with just seasonality. So here's a look at December. You can see it's 0 everywhere except for in December. All right, let's estimate the in sample. So the in sample goes till 1998 April. So the training data is only up to 1998 April. So let me change that. Okay, so our dependent variable is gasoline sales, GS, and now I'm going to add a dummy variable for each of the months. This model is without a constant, because if you add a constant with 12 dummy variables, one for every month, you're going to find, you'll get an error message of a singular matrix. That's in any software, so without a constant. So there you go. Those are the coefficients. So let's take a record of the important statistics. Here's a look at the fitted. So you can see it just goes for, it's the same level. There is no trend. The residuals are showing that trend. So it's probably best to add a trend to this model too. But in the absence of a trend, this is what the model looks like. Okay, so back to estimation output. Let's capture the adjusted R squared for our records. Okay, so Control C. Let's come back to the Excel file for seasonality, adjusted R squared, and then we want the IC and SIC. So Control C, Control V, and then next the SIC. Oops. Okay, SIC, Control C, and then Control V. we'll need the in-sample root mean squared error, for which we need to forecast. So let's go ahead and do the forecast. Again, change the forecast sample for in-sample up to 1998 April. Uncheck the box insert actuals for out of sample, and then forecast and actuals. Okay, there you go. You can see the solid blue line, that's the forecast. The green line is the actual, and then in orange or red, whichever color it appears in for you, those are the 95% interval. Okay, I think this is better. I double clicking on it to easily get the number. Okay, so the root mean squared error, this is the in-sample root mean squared error. Control V. Alright, before I show you how to get the out of sample, let's look back at our estimation output. So there you go, you can see there is no constant. You can model with a constant, but in that case you would have to remove one of the dummy variables. In this case I'm moving D1. As you can see, those are the results. So keep a few numbers in mind. C is 9,845.158, and then the coefficient for D2 is negative 552.7368. Okay. Now let's go back and estimate with the dummy variables to see what's happening here with all the dummy variables. So let's put D1 back. Okay. So you can see D1 and the coefficient for D1 and constant is the same, 9,845. That's because it's giving you the January effect. And then everything else was in relative to that. So if we take the difference between, let's say, D1 and D2, so 9845.158 minus the coefficient for D2, I'm going to type this part, 9292.421. So 552.737. Right, so let's go back, the model with the constant. So there you go. So D2, you can see that's the negative 552.737. That's because it's showing you what the February effect is in relative to January, right? So when you add the constant, the interpretations just change a little bit. So with or without the constant, your interpretation of the coefficients are slightly different, right? But everything else, the statistics and your R squared, adjusted R squared, all should be the same. Right, I'm going to go back to the model with the dummy variable. I'll save this equation. Let's save this as seasonality equation so that I can use this later on. Okay. So now for the out of sample, so again, copy pasting this part so that I don't make a mistake here. Okay, going back. Right, so the forecast sample, uncheck insert actuals for out of sample, and forecast and actuals. This will give us the accurate out of sample root mean squared error. So you can see the blue line over here, that's the forecast, but the green line, that's the actual. It's outside of our 95% band. Okay, so let's copy this number, the out of sample root mean squared error, 5,884. Okay. Paste. So that's our, okay, I didn't copy it right. Let me go back and copy that again. 5,884.806. Control C. Control V. Okay, there you go. Alright, let's go back and forecast this time using the entire sample. So the data set that's available to us is up to 2001. So let's change this to 2001 April. Okay. Alright, so there we go. Those are all our coefficients. Okay. Let's go ahead and forecast then. I deleted an equation, an incorrect forecast. Okay. So let's go to forecast the entire sample, including the forecast horizon. I want to name this so that it's saved. Let's call this seasonality forecast. You can see the forecast is on a level. That's because we have not included any trend. So let's go ahead and include a trend. So I'm going to generate two series for that. One is time. So time will be our linear trend. So at trend, okay. This is for the entire sample, including the forecast horizon. Next, I'll generate another series for time squared. So time underscore squared. This is equal to time to the power 2. Oh, so not time. At time, it's just time, or you could do at trend to the power 2. Okay. So now that we have these two, I'm going to go ahead and estimate the linear model first. So I copy pasted the seasonality model for ease. Okay. And then you can add time wherever, it does not matter. I'll change the sample to our in sample, so that's still 1998 April. Let me verify. Yes, 1998 April. Alright, let's start recording our adjusted R-squared and other evaluation matrix. So our adjusted R-squared is 0.88. You can see that's quite an improvement from 0.01. Let's get the AIC and SIC. Okay. AIC, Control V. Wait a minute. Okay. And then SIC. Right, next we need our in sample root mean squared error. So I'm going to go ahead and forecast that. Let's go back to EViews for that. So forecast, and then this is the in sample, so up to 1998, month 4. Uncheck the box, insert actuals, and then forecast and actuals. Okay, you can see much better. We have the seasonalities, and then we get a little bit of a trend. Looks like there's some cycle in the 80s. Right, but much better than just capturing seasonality. In terms of fitting the in sample. Okay, so I'm copying the root mean squared error. Right, that has decreased from 2089 to 703. Alright, let's get the out of sample root mean squared error. I'm going to copy paste the out of sample. Right, so change the forecast sample with that. Uncheck the box because we want accurate root mean out of sample root mean squared errors. So there you go. You can see the actual is still slightly off from the forecast. Okay, let's get the root mean squared error. Back to Excel. Okay, so it has declined from 5,884 to 2,300 something. Cancel. Okay, so we have statistics for our linear trend model. Next, I want to get the forecast for this series, for the forecast horizon. So let me change the sample to 2001 April. Okay, right, and then forecast using that. I'm going to name this series so that I have it. So maybe linear trend seasonality. So I know it's not just a linear trend, it's linear trend and seasonality. Okay, so no space. Perfect. So it's the entire forecast sample. Oh, forecast, and I'll keep that box checked. Forecast and actuals. Okay, there you go. Okay, so that's the forecast with a linear trend. I'm going to name this equation to linear underscore trend. Next, we're going to estimate the quadratic with seasonality. So not generate series, quick estimate equation. Okay. Let me copy paste the equation because there's quite a few variables. Right, so Control C, cancel. Let me close this out. Okay. Now quick estimate equation, Control V, and then I'm going to add time squared over here. I'll need to change the sample for in sample to 1998, April. Okay. All right. So that's the quadratic trend with seasonality. Let's get our adjusted R squared from here, and the AIC and SIC. So adjusted R in sample adjusted R squared. This fits even better, 2.9. It fits the in sample much better, 2.92. Okay, so then the AIC and SIC. AIC, SIC. Okay. Next, let's look at the residuals and the fitted. So you can see this seems to fit the in sample much better. Out of sample performance will be key over here. Right, so let's look at the in sample root mean squared error. Okay, so there we go. Let's get the root mean squared error. Okay, next we'll work on the out of sample root mean squared error. So let's go back to that. Forecast, change the forecast sample to out of sample. Right, uncheck the box, forecast and actuals. Okay, let's copy the root mean squared error. So this is for the quadratic trend with seasonality. Right, even the out of sample errors are much smaller. So if we look at the numbers now, adjusted R squared is highest for the quadratic with a seasonality. AIC is the lowest, SIC is the lowest for the same quadratic trend with seasonality. In sample root mean squared error and out of sample root mean squared errors are also lower, or is the lowest for this. It's going to be interesting to see just a quadratic trend without seasonality, and then you may also want to check linear trend with seasonality. Most likely the seasonality is important, but still it's better if you want to get a little bit more accurate forecast to see if how important that seasonality is. My guess is that the seasonality would be important. Okay. Now just for the forecast for quadratic trend with seasonality. Okay, so now let's forecast the entire sample with the forecast horizon. I'm going to name this as the quadratic trend seasonality forecast. Okay, keep that box checked. forecast and actuals. Okay. All right, so there you go. You can see this fits the data, the in sample much better, or actually the observations a little bit better. Right, it performed pretty well out of sample as well. Okay, next I want to plot the three forecasts together. Before that, let me name this equation. So quadratic trend, seasonality, forecast. Okay, quadratic trend, seasonality, the equation. All right, I will now highlight the three forecasts in the original series and plot them together. So I have the two trend forecasts, seasonality forecast, and then the original GS gasoline sales. Open them as a group, view, graph, align chart, will do great. There you go. You can see the one that's on the same level. That's the seasonality forecast. Whoops. Okay. The red is the actual data, and then the orange, I think the orange is the quadratic. So yes, again, it's hard to differentiate because it fits the actual so well. And then if you look closely, there is the blue line underneath, which sort of under forecasts the more current years. So there seems to be a slight increase, more than a linear increase in the recent years in gasoline sales. Okay. Going to freeze and name this graph, or you can just name it. It should also save it, but I'm going to name that automatic. Okay. And then name just forecast graph. Right, so there you go. You now know how to model seasonality and then also model seasonality with trend. Okay, it would be worthwhile to compare these models without the seasonality as well. Okay, so here I'll do that. I'm not going to go through all the steps for the trend models. I'll let you do that on your own, but I will show you the results. After getting the forecast statistics or the forecast evaluation matrix, I still find the quadratic trend with seasonality to be the best model for the data set that we have. Right, I'm going to go ahead and save these as completed. Same thing for the file. So name the equations and then save everything in place so that it's easier to reach in the future. All right, so now you know how to forecast seasonality and how to forecast seasonality with different trend models.